Continuously variable transmissions, or CVTs, are more common than you think. Audi, Subaru, Nissan, Ford, GM, and other automakers use CVT transmissions in their cars and SUVs. There is no way to avoid them. Chances are there's one in your shop right now. So what does a CVT transmission mean for technicians? On the maintenance side, a CVT transmission requires more or the same frequency of filter and fluid changes as a conventional automatic transmission. And many of the basic procedures are the same. On the diagnostic side, a CVT transmission is less complicated internally than a 6 or 9-speed transmission. Diagnostics with a scan tool are about the same. On the service side, you may never pull a variator or belt out of a CVT transmission. You can service components like sensors, pumps, and valve bodies. The point is not to fear a customer complaint about a CVT transmission. So how do you know you're working on a CVT transmission? This is tricky because a CVT transmission is about the same size as a regular automatic transmission. The only indication might be the shape of the case, and in some CVT equipped vehicles, the shifter might lack a low range, but some CVTs might have a sport mode or even paddle shifters in the case of some Nissans. Otherwise, you may never know you are driving a CVT. A CVT does not have conventional forward gears. Instead of 5 or 6 forward speeds, a CVT transmission has a single belt or chain attached to 2 pulleys that vary the diameter and change the gear ratios. This allows the engine's input to operate at a constant RPM while the output speed of the transmission changes. Think of it as having an infinite number of gears that can be selected for any situation. There is nothing magic about a CVT, but there are some unique diagnostic, service, and inspection procedures that need to be followed. Let's cover the basics. Here we have a CVT that can be found in many vehicles. Where it attaches to the flex plate of the vehicle, well, we have a torque converter. Some vehicles use a torque dampening disc or even a clutch that resembles one you might find on a manual transmission. Disc clutches are more common on CVT transmissions found in hybrids. Behind the torque converter are discs, there might be a pump. This is very similar to conventional automatic transmission pump. But many CVT transmissions, it generates considerably more pressure than a conventional automatic transmission pump. For example, some CVTs create more than 700 psi. Some pumps are powered by the input shaft. Others might have an external power like a chain on some Jatco and Ison transmissions. There are typically 2 clutches next to the input shaft that locks the sun and planetary gears. These clutches are used to engage forward and reverse. Now we have the conical pulleys or variators. This is the heart of the CVT transmission. These have a groove that a belt or chain rides in. The conical plates of the variator are angled. As the plate's distance increases, the belt is forced outward. This changes the diameter or the gear ratio of the variator. Connected to the input variator is a chain or belt, and the output does the same trick as the input variator. On some transmissions, the input variator is called the primary variator. The position of the variators is controlled by the hydraulic pressure generated by the pump and controlled by the valve body. The base of the variator is a hydraulic chamber that controls the position of the conical plates. This arrangement is why the pump has to produce so much pressure. With the input variator open and the output variator closed, we get low gear, where the input shaft or variator has to spin several times for every turn of the output variator that only turns once. This multiplies torque and gets the vehicle moving from a stop. Let's reverse the variator position. With the input variator closed and the output variator open, we get overdrive, where the turn of the input shaft equals 3/4 of a turn of the output shaft. A CVT transmission will change position of the input and output variators to give an infinite number of gear ratios. This allows the engine to remain in the power band where it is most efficient. The belt or chain can have more than 400 parts. There are more than 300 of these plates or elements that grip the plates of the variator. The elements are held together using steel bands on either side. This type of belt pushes the output cog. A chain is typically used instead of a belt, where vehicles have more weight and more power. With this one, it pulls instead of pushes the chain itself. During normal operation, the chain or belt will shed some metallic debris that you might see on the magnets of the filter. The fluid path for these transmissions is designed to keep the debris out of the valve body. On the output shaft, the power is transferred to the final drive and differential on the transmission. On some CVT transmissions, the output could be attached to a start clutch. The start clutch connects the transmission to the final drive. The clutch is controlled by the valve body. This is common on some Honda and Toyota CVT transmissions that can be found in hybrid vehicles. As you can see inside this case of a CVT transmission, there's nothing really exotic or overly complicated. In the next lesson, we're going to cover some diagnostic procedures and some service tips.